Hey guys, welcome back to AlgoYogi. We have completed the tree series. Congratulations. Our next topic would be linked list. As you guys have recommended that in the comment sections. I'm just kidding, you have not. I don't even know if you're watching my videos, but I like it. I love making it, and it helps me, it helps you guys. And this is a wonderful website that I've created for tracking the problem. So it's lovely work. All right. So reverse linked list. That's our first problem in the linked list. So we'll be wrapping these easy problems. There are like 8 problems. So let's begin with reverse linked list. So given the head of a singly linked list, reverse the list and return the reversed list. Easy peasy description. It's a normal data structure like a list, but here you don't have like in place accessibility of these values. You just have to go follow the pointer and then reach at some point and then get the value, whichever value you want, I meant to say. But anyway, that's not the point. The point is to reverse this. And how are we gonna do it? Let's see how we're doing it. Let me switch the view. So before we dive into, since it's a first problem, I just want to go over the list node data structure. So basically this is going to have value, and that is int type, and then we have next pointer, which is of type list node. All right, so it can just point to the next node, what I meant to say. So this is the type, and also this is singly linked list, and there are doubly linked list, and we might see problems related to that. Just remember, along with next there is a pointer called previous, so that is just you from any node, if it has a previous node, so you could just go, rather than going just next, you could go previous. So it does help in some cases where you want some you reach up to a point and you want constant time complexity. It's like you want the maybe like the last element, and you want to go over there and start traversing backward, so you could just follow with the previous pointer. But anyway, that's not the point of this problem, so let me get rid of this, because our job is to reverse it, and that's going to be very easy. How are we going to do it? So let's say if it was just one node, that means what? Like it was pointing to something called none. That means it's pointing to nothing. So then in this case, how are we going to reverse a linked list when it's just one list node? We do nothing. We just return the same thing, because at the end of the day, it would be just this will help you think clearly. So this is what we're returning, but aren't they both same thing? They are, right? They are, right? But how about if we had two nodes? So my bad, let's say two nodes, and this is definitely pointing to none. I'm just keeping it here just so that it is still pointing somewhere, and that will help us in a way when we when we actually deal with a lot of linked list problems. So now the reverse of this would be 2 pointing to 1 pointing to none. How do we do that? We basically, one of the ways could be you take all the values, you visit all the values, store them into a list. That's a brute force approach that will take big of n time complexity and big O n space complexity, and that is what we don't want. We just want to keep it limited to like just the runtime, time complexity, and rather than use up any space, because we have pointers here. We want to play around with the pointers. That's the point of linked list. Otherwise we could have just used some normal list, even asking us or you guys like as a question. But anyway, Now, so how do we play around with the pointer? So tell me, if we are basically visiting these nodes in such a way, let me just remove this, and my head is over here, and then how about I basically say, let's say this is my current pointer, this is my current pointer, let's not just, let's not refer to head, this is my current pointer, and then I will start a while loop so that I process all the nodes. So I start basically a while loop while, let's say, while my current pointer is not none, then I will have something called next reference, and next would refer to basically current.next, cur.next. So that's where my next is pointing. I don't wanna, come on dude, I think it's somewhere I do something to get rid of it, but I'll do it later maybe, maybe I'll do it right now. Pen setting, and where is it? Oh yes, all right. Oh yes, it's a 2. If you know the reference you would, but if you don't, sorry. Anyway. But anyway, next is pointing to cur.next. So now this is my next. But one more thing I want to do is I want to have a previous pointer. So initially I'll make sure that my previous is pointing to this, or it could be just, let's say, none. But initially we can just say it points over here, or maybe it would be better to think if my prev was at pointing somewhere called none. Now it's not attached to the this list that we are trying to reverse right now. So its previous is not attached to it right now, but let's just understand the logic. So current is basically pointing over here, but now next is pointing to the next node. What I'm going to do is point my current's next to previous. So cur.next would be now at previous. So I'm getting rid of this pointer. See, so now these are two linked lists right now we have, and we point it over here, and then I will point my prev to current. So my prev would now, instead of this none, would point to cur. And further, just one more step, one more thing would be pointing my cur to next. That's it, next. So this current reference is gone from here now, and it's pointing to next, right? And sorry, my bad, this was my prev, but still, you see, like, these are not connected right now, but they will connect, right? I don't know why I wrote this next, but this is current. They're not connected right now, but because my current is still not none, so that means I will go over this loop one more time or two more times, we don't know, but because it's a while loop and it can, until the condition is satisfied, it will keep going. Again, the same thing is going to happen. Current will, rather than pointing over to the next, but making sure that the next goes over here first, because that's our first statement in our list, basically this list of statements. And then my current will point it next as here. My previous, it will bring the previous, my bad, it will bring the previous over here. This this is gonna get rid of, and then my current will go over here, and it's my previous that will be the answer, and I will return, oh my god, it will return this as an answer. All right, I know the presentation hasn't been the best over here, however I am sure you're not looking for the presentation but the logic, so please follow the logic and please code it yourself. Don't look at the code, just solve it yourself, and if you can't, then only go to the solution. But I am going to code it for myself. All right, so let me switch the view over here. Let's zoom in, and caps is on. We don't want it on, so that's what I say. I will have current pointing to my head, then I will have a previous pointer. What's that doing is pointing to, let's say, initially to none, because even in a normal list that we're trying to reverse, the last node, a valid node, list node I'm talking about, is pointing to none because it doesn't have anything. So currently previous is pointing to none. Then we're gonna start a while loop while we have our current pointer node pointing to none. Then we're gonna have next. I can't write next next because that's a reserved keyword. All right, so next would be cur.next. Fair. So what is it now? So cur.next would be previous. What is previous? Now previous becomes my current, and my cur becomes next. That I initially saved, because my now these two do not have any common pointer. It's the current that we basically need, because current is linking to previous as our next node, and now I want to go back to the next. Initially I saved as a temporary pointer, so that I point to, and I can just access that later and again start my same process. Initially previous we created as an independent list. We can say it's a independent linked list that we created, but now we linked it, just sending one node to the previous, making sure we are pointing the opposite way. And now finally we just return previous. That's it. That's the entire code. It's a LeetCode easy problem, so what do you expect? All right, let's submit it. Did I submit or run the problem? Okay, I was running the examples. Now we are submitting and it should be accepted 100%. All right, let's write down. And I said there is a brute force approach, which is visiting all the nodes, basically while cur.next, and store them into a list, and then in that list visit the list after reversing it, or from basically using for loop on the reverse list, or just visiting them from last index to the 0th index. And you guys are smart, you'll do it. But let me just write the time complexity. I just don't know. Complexity, yes. Time complexity would be big of n. N is the number of nodes, list nodes, and space complexity in opposition to big of n in the brute force approach. We have constant space complexity, right? This is sweet when we have something constant. That is the best. All right, so let's go to AlgoYogi, mark this problem solved. All right, and once I have the solution up, I will append it over here. All right, see you guys in the next problem. Until then, bye bye.